Challenges and limitations in implementation of swarm intelligence for big data and cloud computing. Presenters: Hassan Sohail, Zenia Zamir, Hafiz Farhan Ahmad, Usama Iqbal, Pir Ahmad Ali Shah. University of South Asia Cant, Lahore, Pakistan. Contents are: Abstract, Introduction, Challenges and Limitations, Solution, Algorithms, Path Locator Algorithm, Action Performer Algorithm, and Conclusion. Nature always motivates us and gives solutions. Purpose of this paper is list out some of the limitations and applications that are aroused in the way to implement a natural phenomenon of swarm intelligence for big data and cloud computing, and some suggested solution to solve these problems. This paper is about the challenges in the implementation of swarm intelligence in natural computing. It is also known as natural computation, and consists of three types. The first one is solve human begin problems by getting inspiration from the nature. Second, synthesize the natural phenomena by the computer. And third, use natural material for computing. We have focused on the first type of natural computing. Natural computing has many fields. Few of them are artificial life, DNA computing, quantum computing, immune systems, quantum computing and swarm intelligence. Swarm intelligence concept given in 1999. Some of the major achievements are SI routing algorithm that was ANT-based control, also known as ABC. They have also give us an algorithm for Wi-Fi and cabled network. Some techniques of swarm intelligence are used for data portioning, also in web data mining and in many more. After studying natural computing on broad level to understand how to get inspiration from nature, and what are the types of natural computing, with deep understanding like neural computation, artificial life etc. Then we studied what are the challenges occur while implementing a real ant in artificial world, which lead us to the challenges and limitations in implementation of swarm intelligence for big data and cloud computing. After studying a lot, we listed out two major challenges and limitations. The first one is knowing the nature of pheromone. The real ant ejects pheromone from their body to guide the directions and other ants sense and follow it for reaching their target. Till now the properties of pheromone psychochemical is not divulged completely, therefore it's hard to implement it in artificial way. The second challenge is that the real ant sense the pheromone with the help of its antennas. So, when it reaches half of the way she senses directions by pheromone and decides where to go, but how the robotic ant will find out the right direction if the artificial pheromone is on multiple sides with equal concentration, and how ants distinguish their pheromones during trailing the pheromones. The first challenge can be achieved by using liquid methane as a pheromone in an artificial ant. When the robot ant starts its journey, it will emit liquid methane from its body, and other ants will trail that liquid methane to follow that ant. The ants will get confused when the concentration of the liquid methane gas is same at two different directions, then the artificial ant doesn't know where to go. This problem can be solved by setting the direction of robot ant that depends on the geometrical configuration of connecting points or nodes. The precise angle of these branches will affect the route to be followed by ant in a network of nodes or path. As a result, these angles can influence the ant's ability to properly track a pheromone trail to a destination. We have proposed two algorithms for achieving these challenges. The first is path locator and the second is action performer. The path locator will used to find the destination and to find the shortest path between the starting point and the destination, while the action performer will used to give the direction to the other ant robots. When the robot will start its journey in sensing the artificial pheromone and emit liquid methane gas which act as pheromone, during this journey if the ant will find any other shortest path than the robot ant will start following that direction. After finding the path and collecting information, the other robot will start their journey, and start trailing the liquid methane gas by sensing it, and robot will choose only that path whose liquid methane gas concentration is higher than the other. With trailing the liquid methane gas, ant robots will reach their destination, After reaching to their destination, they will perform their desired task or work. On task completion, the robots will return back to their nest. This process will continue till their mission is accomplished. We have found the method to implement the pheromone by the liquid methane gas. Artificial ant will emit the liquid methane gas during the journey, and the other robot ants will trail that liquid methane. The other major challenge that we will face is that the ant will confused when it is in mid of the path. This problem can be solved by making network of the paths and node between them. Then we have introduced two algorithms that were used to make robots that can work like a real ant. For any query, kindly mail us on the following at any time.